We're talking about integrals, and the fundamental theorem of calculus actually relates differential calculus and integral calculus all together in one package. And there are actually two fundamental theorems. I think we'll only talk about one of them because the other one is more like useful for computations, which podcasts, so we're not going to do that.
Not gonna get into that.
But one of the versions, or one of the parts of the fundamental theorem of calculus is that the integral of the derivative of a function is equal to the function itself. What does that tell us? Okay. Well, this tells us that if you take a function, differentiate it, and integrate it, you get the same function back. And so why is this important? This tells us a lot about how to compute an integral, right? Let's say we have the integral of a function, and you want to say, okay, equals to, well, what? Okay. As soon as you look at the function that's inside, it's called the integrand. As soon as you look at the integrand, you need to think of that integrand as the derivative of some other function. Because if you can figure out what that other function is, then boom, that's your answer, right?
Also, though, plus C.
Yeah, but
I forgot about the plus C.
But there's no plus C in.
Well, there is a plus C.
Not in that part of the fundamental.
Because I'm just thinking about this.
Oh yeah, there
X
is.
squared. You differentiate
right.
it. 2x. You integrate it.
You're right.
X squared plus C, right? It would have a plus C.
Yeah, you're right.
So there would be a plus C component. So I guess there's some, because again, this plus C, if you already have some value that you're evaluating this at or something, like it would simply be that initial starting point. But if you don't have anything, this still gives you a very good idea of what the function actually is that you're trying to solve for. And that's what's important, because you're trying to solve for f of x here.
So I'll actually
or whatever the function is.
I'll actually explain what the plus C is, because Rayal just said plus
I guess
C.
I didn't even. Oh yeah, sorry. Go ahead.
So
maybe you want to do that.
This is actually something that first year calculus students forget all the time, and it's that when you find the antiderivative of a function, the most general form is actually like plus a constant. And this is actually pretty interesting when you think about it, and I will help you think about it right now. So when you take the derivative of a function, okay, we all know that the rate of change of a constant is 0, right? So if I take the derivative of x plus 2, the rate of change is going to be 1. And if I take the derivative of x plus 1,000,000, the rate of change is still going to be 1. Okay, which means if you give me the derivative of a function and you say integrate this function, or give me the antiderivative, the thing is there is not one single antiderivative for one derivative. It's actually a family of functions which can differ by a constant. Okay, so for example, if you tell me, okay, what is the antiderivative of 1, which is the example I just gave you, I can't just say it's x, right? Because if you differentiate x, you get 1. That is true. But as I just said, if you do x plus any other constant, it will give you the same derivative. So that is why we put plus c, because the antiderivative of 1 is x plus any other constant. And this is obviously true in the general case for any function you pick. The antiderivative is just a family of functions that all differ by a constant. So the general case, you will have to just do plus a constant c.
Mm-hmm. And these integrals are like, these families of functions is kind of interesting, because when you integrate, you get this family, but when you differentiate, you get this one number. And it's also important to note to note that this is like the indefinite integral, because because we were talking about integration like it represents something. So when we're talking about integration, like integrating from some interval, like some open to open or something like that, any interval basically, we're talking about a physical meaning. We're talking about the area under this graph, if that's what we're doing, right? Yeah, so like we're talking about something physical. But when we're talking about the indefinite integral, we're no longer necessarily talking about something physical. We're now talking about something a lot more mathematical. Like we have some curve, and if we want to know the area under any possible interval, we get this indefinite version that we can just plug in values into, right? So we basically have this idea of indefinite integral where it returns a function, which is kind of different from our original notion of what the integral is, which is an area under a curve, which represents the area and not necessarily just the function.